Hello, everyone, and welcome to my talk, Event-Driven Architecture for the Win, Successful Strategy for a Journey to the Cloud. The goal of this talk is to take you on a journey that we've made with one of our customers in order to modernize their architecture using event-driven architecture and Azure Cloud Services. Before we start, let me quickly introduce myself. I'm Mirna Alaisami. I work as a technology consultant at a company called Novatech. And in my daily job as a consultant, I try to advise and help customers with building their cloud architectures and infrastructures, with migrating their workload to the different cloud platforms, with enabling and training them on topics like Kubernetes, Cloud Foundry, CI/CD tooling, cloud native methodology, and so on. So I try to help them to choose the most suitable solutions for their use cases. And very briefly about my employer, Novatech is a company with around 250 to 300 employees. We have 7 branches in Germany and 1 in Granada, Spain, with the main branch located in Stuttgart-Echterdingen. And our main work lies around modern software engineering, agile methodology, technology consulting with topics like cloud computing, application performance management, Internet of Things, and many other things. Now, before going with the journey itself, let's have a look on the story behind that journey. So what led to all of that? Why did the customer come to us and ask for help the first place? We were dealing actually with a great customer. So our customer was one of the leading machine manufacturers worldwide. They create and sell high quality machines around the world. However, they recognize that they are facing a lot of problems with specific use cases they have. And it seemed with the time, unfortunately, that their IT architecture is a little bit outdated and needs modernizing. And having a look on some of those use cases, they were dealing, for example, or they needed to maintain a huge amount of unstructured data in various systems. So having file sharing systems, CRMs, different databases, and so on. Those data are produced by their machines, and they had some technicians who can fill out those data, upload them, edit them using some interfaces and through VPN connection, which seemed to be that it's a very time-consuming task and causing a lot of problems. In more details, they had an application. The technician comes and uses that application. The application opens a Windows shared folder through a VPN connection using some server message block protocol, file sharing protocols, in order to upload the data and save it on their local data center. And having a look on that picture here, you can imagine the kind of problems that may occur when the connection or the network is not so stable. And that's why they came to us and asked for help. And here we came into the scene and we said, well, let's move to cloud using event-driven architecture. And you may think here, yeah, that seems to be great, but why? Why did you take this decision at all? And in order to answer that, let's have a look on that here. As we said, our customer recognized that they are facing a lot of problems. They have some use cases which are time consuming. They don't have the right solution for their use cases. And they already started looking for a solution. And while they were searching for a solution, they came across the term Agile integration. And they read a little bit about it, and they thought, well, that seems to be very interesting, and it seems to be a solution to our case. However, we still need some support here. And that's, by the way, how they came to us and asked for support here. And if you want to define or summarize Agile integration in few words, we can say that Agile integration is the approach of moving away from the traditional centralized integration models using SOAs and ESPs into a more modern decentralized integration model using microservices, container-based applications, cloud-native architectures, and allowing the communication between those applications or microservices via events and APIs, and aligning all of those integration elements with Agile and DevOps methodology. So talking about Agile integration, we are talking mainly about three main aspects. We are talking about the distributed ownership between the different teams, allowing those teams to work on their microservices independently without having a central integration team to which we defer all the integration tasks, and which may be a bottleneck, which may be quickly a bottleneck in the whole process. And we are also talking about a fine-grained, delivery-focused architecture using some specialized, right-sized containers and microservices. And we are also having a cloud-native infrastructure for our applications. Which benefits does Agile integration bring with? Well, it's for sure, or it improves agility, since, as we said, we are talking about different teams that are working independently on their microservices. We don't have a central team anymore, which used to be a great team doing great work in the integration area. However, they didn't have always a good idea about the applications themselves and the requirements there, which was a little bit error-prone task and slowing the whole process. Also, those microservices can be deployed, developed, changed, and built independently, having their own production line, which speeds up the whole production process and leads to a safer application of changes. It also improves scalability, since those microservices can be scaled independently on their own, making use of the elastic scaling features of the cloud infrastructures. And it, of course, also improves the resilience, since those microservices can be deployed isolated from each other. They can fail over and recover in runtime without affecting each other or affecting their shared resources. So that's why we actually try to move to cloud, to a more cloud-native architecture, and try to make the communications between our microservices via events, because as we will see later on, our use case fits very well with having an event-driven architecture. Now that we have seen why we thought at the first place about cloud and event-driven architecture, it's the time to see why we chose some specific tools and services. Because as we will see in the next steps, in each step, we had different choices. All of them were great choices. They have their pros and cons as usual. And it was very important to know like which one is the most suitable solution in our case. So starting from the cloud provider, do we use Azure? Do we use Amazon Web Services, Google Cloud Platform, or any other cloud provider there? And in our case, the customer already had an Azure Enterprise Agreement, and they also had Windows native servers. And as we all know, Azure is a very good destination for Windows servers, and it provides a native support for the Windows Server workload. So it made sense in this case to start with Azure as a cloud provider. Then moving to the event-driven architecture platform, we also had the chance to use Apache Kafka, or maybe Confluent Cloud, or why not Azure Event Hub, or any other platforms that support event-driven architectures. And having a look on the first three options that came to our mind, Apache Kafka was a great option. It offers a lot of features. However, in our case, we still needed to install and operate it. And moving to Confluent Cloud, it's also a great option that enables us to use Apache Kafka as a fully managed service and make use of all of its great features. However, the customer still needed an enterprise agreement in this case. And moving to Azure Event Hub, it's also a fully managed service, very similar to the features that Apache Kafka provides, with some small differences. And the customer had already an enterprise agreement with Azure, as we mentioned. So we said, why not start with Azure Event Hub, since it's the fastest to implement in this case. As we mentioned, we wanted to start with fewer infrastructure components, and we didn't want to install and operate anything. So we wanted to use a fully managed service. However, we still wanted to avoid vendor lock-in when it comes to event handling. And since Azure Event Hub provides an endpoint which is compatible with Kafka clients, we thought, yeah, why not use Azure Event Hub with Kafka applications or Kafka clients? Now, moving to the data storage, we also needed a place where we can maintain a huge amount of unstructured data and have fast upload and download mechanisms. And we had the choice to use either Azure Blob Storage or Amazon Simple Storage Service or Google Cloud Storage or any other services. However, as we said, we already decided to use Azure as a cloud provider and Azure Event Hub as an event-driven architecture platform. And Azure does provide a very good storage account service that fits very well in our case, where we can upload and download the data very fast and also maintain this huge amount of unstructured data. So we decided also to try to use Azure Blob Storage as a data storage solution in this case. Now that we had a look on why we moved to cloud and event-driven architecture and why we decided to use Azure as a cloud provider and then Azure Cloud Services along with Kafka applications to implement everything, it's the time to deep dive into the solution right now. So starting with the business logic, as I mentioned, the customer had a specific business logic, which led to using or deciding to use events to communicate the different microservices that we had or the applications that we had, and also to choose some specific tools for that. So as mentioned, they had different machines. And those machines or one machine can belong to one or more geolocation. In those geolocations, the customer had different local data centers to which they want to download and save their data. So, and also important to mention that they had also a central location where they had also a local data center, and the local data center there in that central location should download all the data which are uploaded about all their machines. So whenever we have a technician that comes to upload something about a specific machine, some data about that machine, those data will be uploaded or should be uploaded to Azure Blob Storage. And then they should be always downloaded in the local data center in this central location, as well as in all the other geolocations to which that machine belongs to. And only after making sure that those data about the machine have been uploaded in the central location and in all the other geolocations that the machine belongs to, they are allowed to be deleted from the Azure Blob Storage. Now, having a look on Azure Event Hub, in Azure Event Hub, we have the Azure Event Hub namespace, which is the management container for all our data. And inside it, we have the different hubs that will store our events and event streams at the end of the day. So coming from the Kafka word, this Event Hub namespace will be the Kafka cluster, and the different event hubs are the Kafka topics in this case. And going inside one of those event hubs, we can see that we have different partitions there, and each partition will have a subset of our events or event streams. And usually the events are stored or received in one partition exactly in the same order they are produced with. However, not across the different partitions. And if it's important to us to keep the order of the messages or the events that are sent, or to aggregate them according to some specific attributes, in order to do that, Azure provides this partitioning key feature, which enables us to do that. So we can send our events with some specific keys, and then Azure Event Hub will use a hashing function on that key to decide how to assign the different events to the different partitions, making sure that all the events that have the same key are always assigned or saved on the same partition. And in that way, we can make sure that we can consume all the messages having some key in the same order from one partition that we send the messages or the events with. And in our case, we used, for uploading the data, we used the machine number as a key. And when downloading the data and saving the events about downloading the data, we used the machine location as a key. Now, as we said, we have our hub, we have our different partitions. We have on one side our producers that can use some keys to send those events to Azure Event Hub. And on the other side, we have our consumers, which are listening on those hubs and will receive the events. And we have the possibility to group the related consumers to the so-called consumer groups, making sure that each consumer group will have its own view of the whole event hub, and it will receive all the events from all the partitions in the event hub. And this helps, for example, when we have different applications, then we can define different consumer groups for those applications, making sure that each application will have its own view of the whole event hub, and it will receive and process the events on its own base, independently from other applications or consumer groups. So the consumer group or one consumer group will always receive all the events in the hub, and they will be distributed among the different consumers inside that consumer group, making sure that one partition is being read or assigned to one consumer in that consumer group at a time. Another important feature that Azure provides is the Azure Schema Registry, which is a repository where we can save and manage our schemas, and then let our producers and consumers use those schemas to serialize and deserialize the event data. So we don't have to exchange those schemas between the producers and the consumers anymore. We can save them in those schema registry. We can reuse them. We can define some relations between them using the schema groups. And in our case, we use the Afro type as a serialization type, which reduce the bare message overheads compared to other types, since we don't have to send some metadata like the field names or types anymore with the events or the messages themselves. Now moving to Azure Blob Storage. Azure Blob Storage is organized in this way. We have the Azure account or Azure Storage account, which is a unique namespace that will contain all of our data inside it. And inside that account, we will have different containers. And inside our containers, we can put our blobs, being text files, binaries, images, etc. And the way how you structure your Azure Storage account depends heavily on your use case. So for example, in our case, we decided just to put specific containers for the different locations, and then inside them put the all the related blobs about a specific machine in one container. So if we have a look on that solution at a glance, we see that we have our Azure infrastructure on one side and our on-premise applications and local data centers on the other side. So for our customer, we defined an Azure Hub namespace, and inside it, we created two hubs, one for storing the all the events that some data have been uploaded about some machines in some locations, and the other one, the data downloaded one, for storing all the events that the data have been downloaded in some specific locations. And we also created an Azure account namespace for our customer. And we, as I said, we decided to organize all the data inside some specific containers there based on the location and the machine number. So now we have our downloader, uploader, and cleaner services on the other side, or application. And whenever the technician comes and uses the uploader application in order to upload some data about specific machine, along with some metadata about that machine, the data will be sent to Azure Blob Storage. They will be saved or uploaded to the right container there. And then an event will be published to the data uploaded hub, saying that some data have been uploaded about that specific machine in that location. Then we have our downloaders, which are listening to that data uploaded topic, which will receive the events. And in the central location, they will always download the data and publish an event to the data downloaded topic, saying that we in the central location downloaded the data about that specific machine. And all other downloaders in the other geolocations will decide based on the machine location. If it equals to their location, they will then download the data and send also an event that they downloaded the data there. Otherwise, they will just ignore the event and not do anything. They will not download the data there. And we have also our cleaner service, which is listening to the data downloaded hub in this case, and it receives the events that the data have been downloaded, and it should make sure that the data about the machines have been downloaded in the central location and in all the other locations to that the machine belongs to, before deleting the data from the blob storage. And only after making sure that those conditions are met, it will delete the data from the blob storage. And yeah. Now, having a look on that picture here, maybe you can see that there's still something missing in the whole picture there. So having a look on that solution here, maybe you missed something. I'm pretty sure you have a lot of creative ideas here. I don't know if some of you have an idea what I'm referring to here. I know I can't see the chat here anymore to see if anyone mentioned anything. Oh, nothing. Okay. So yeah, what I'm referring to is, of course, we are missing something here. And let me just go back to my slides here. We are missing some security aspects, aren't we? Like we wanted, for example, to encrypt our data and store it on Azure encrypted, and then decrypt it while downloading it and store it on our local data center decrypted. And that's why we needed to use some security components like the Azure Key Vault in order to achieve that. So we decided to create an encryption key there and let our uploader and downloader services use that key in order to encrypt and decrypt the data, the machine data, while uploading and downloading them. Another important component that we made use of is the Azure Active Directory, which is a cloud-based identity and access management service that we can use to manage all of our authentication and authorization aspects. And in Azure, we have always the so-called Azure tenant, which is a single directory associated with a single organization. And always when we are talking about a single Azure tenant, then we are talking about a single Active Directory instance. And inside that tenant, we can have 1 to more subscriptions, which are just billing boundaries for our services. So all the Azure resources which needed to be billed together will reside in the same subscription in that way. And then after having 1 tenant for our customer, having a subscription there and deciding to put all of our resources in that subscription, we needed to register our application in Azure. And registering an application in the Azure Active Directory is the process of adding an identity for your non-human users, so to speak, to the Azure Active Directory. And we did that for our applications. We registered them there, and with registering the application in the Active Directory, you create 2 objects, the application and the service principal. The application is a unique application object, which is, you can see it as the global representation for your application across all the tenants. However, it resides in the home tenant where you created or you registered your application. And the service principal is the object that will manage all the access policy and permissions to the different subscriptions in 1 tenant. So it's the local representation of your application in that tenant. And you can always define different service principals for your application across the different tenants, for example. Now, after registering our application, we needed a way to authenticate our application against the Azure Active Directory. And in order to do that, we created some passwords for our applications, which is called the client secret in the Azure world, and then use those attributes like the client ID, the client secret, and the tenant ID in order to authenticate our applications against the Azure Active Directory. However, those client secrets have some expiry date, and we needed to have some cron jobs which will manage the whole process and make sure that they renew those client secrets at the right time. and then store them in a credential, encrypted in a credential database on-premise for the customer, where the application can refer to those databases and retrieve those values. So for example, this is the way how you can configure that in Java. You define your environment variables, you define those attributes like the tenant ID, client ID, and client secret as environment variables. And then using the Azure SDK, you can create an instance of the class client secret credential here, giving it those attributes in order to create an instance of it, and then use that instance later on to authenticate your application. Then we needed to authenticate our users. So on the front end side, on the uploader side, we also needed to authenticate our users to use the application. And to do that, we made use of the OpenID Connect middleware to delegate the sign-in of the users against the Azure Active Directory. Then we needed to authorize our users to use that application, because we didn't want to give the permissions to all of the users. We wanted to have a way to give that only to some subset of our users. And in order to do that, after registering our application in the Azure Active Directory, we defined some app roles for our application. And then we assigned those app roles to some specific users. Then in our code, we configured that in a way in which we say only the users having those application roles are allowed to upload some data. And the way you do that, for example, in Spring Boot, is to put this annotation here on top of your method signature, where you which you use to upload your data. So you use the annotation pre-authorize to make sure that the expression here is met. And in this case, we are making sure that the role claim, which is returned in the ID token, have the app role equals to Azure upload. So we called our app role, for example, Azure upload. And then it will make sure that only the users which have that role defined in their Azure Active Directory can do the upload. Now we authenticated our applications to use Azure or against the Azure Active Directory. We authenticated our users to use that application. We authorized our users and gave them some permissions to use that application. However, we still need to authorize our application to use the different Azure resources that we need, like the Event Hub and the Key Vault and so on. And in order to do that, we also had different options there. So for example, for Azure Event Hub, we could do that either with the OAuth2 or the shared access signature way. For the Azure Blob Storage, we could do that either with Azure Active Directory, so using the role-based access control, or the storage account access key method. And for the Azure Key Vault, it was either Active Directory or the Key Vault access policy method. And for the Azure Schema Registry, it allows only using the role-based access control or the Azure Active Directory method. And in our case, we decided to standardize our authorization process there and give our application a fine-grained permissions across the different Azure resources. So we decided to stay with the Azure Active Directory RBAC method or OAuth method. And the way you configure your Kafka application in Java, for example, to connect to your Azure Event Hub is this here. So the important things like you add the endpoint of your Azure Event Hub, giving the Event Hub namespace here in the server property, and giving the port, the right port 1993, which is the port on which Azure Event Hub exposes the Kafka endpoint. Then giving the security protocol. So here we're saying we are using the SASL framework to authenticate and the SSL protocol to encrypt our transit. Then determining how you want to authenticate. So in our case, it was the OAuth method. And you can also configure your Java authentication and authorization service, giving the login module in this case, and then like give the handler class that will handle your callback after authenticating. And that being said, let's move to the demo. By the way, before starting with that, I just want to mention that the code that I'm using for this demo is in .NET. However, I'm pretty sure that you are very good developers and it should be a straightforward task for you to convert it to Java. And as I mentioned, I showed some important steps how to configure the important things here in Java. But if you still have any questions there, feel free to ping me. Now, before starting with our demo, what I want to show is, imagine that we want to use our old architecture, so the application that opens that Windows shared folder through a VPN connection using some SMB protocol. If we have our technician, for example, on a business trip, they are sitting in some hotel room where the connection or the network is not very stable, and they want to try to upload some data using that old architecture. They will most likely end up having some kind of these messages here. And now let's try to simulate that with our new architecture. And in order to do that, I will use the Google Chrome feature that enables us to add some network throttling here. So if we go to the network here, we can see that the default one is no throttling. However, I can say, for example, I want to use a slow 3G option here. And then, yeah, one thing that I forgot to do is to start the application, sorry. So let's start the front end part here and then go back there and try to use that slow 3G network. So I'm just going to make sure that it's taking the changes and then try to upload some data using that slow 3G network and see what happens. So let's say we want to upload something that belongs to Stuttgart here, and I will use the file with this data to do that, and then upload the data using that slow 3G network and see what happens compared to the old architecture using the Windows shared folder. And as you can see, it's relatively fast. The data has been uploaded successfully with a huge difference to what we can imagine using the old architecture. And now just let me go back to the no throttling option, otherwise it will take some time, and go back to our Azure storage account here to see what happens. So if we are in the containers inside our Azure storage account here and we refresh the page, we can see that we have a container created for Stuttgart here, and going inside it, we see that we have some files uploaded here. Going inside that and trying to editing, we can see that the data has been uploaded, encrypted there. And if we have an overview here about that, we can see that the data have been uploaded with some metadata about the machine itself, which are base 64 encoded, except for the encryption data that Azure expects to have unencoded or unencrypted to be able to read the key value from there. Now let's just try to upload something else, like belonging to Hamburg, for example. So I'll just upload some data there and make sure that it has been uploaded. So let's go back to our containers here and refresh that to see that we have something uploaded in Hamburg there. Then go to our application here. I will use 3 consumer groups in the 3 different locations, so in Stuttgart, Hamburg, and Frankfurt, assuming that Stuttgart is the central location that should always download everything. And I will start, so let me just start that quickly. I will start the consumer groups in the different location, and for Stuttgart, I want to start 2 consumers in that consumer group. And for the other locations, I will start only 1 consumer in each consumer group. So for Hamburg and Frankfurt, I will start only 1 consumer. So the 2 events should be distributed between the 2 consumers here in the Stuttgart consumer group. But for Hamburg and Frankfurt, they should receive everything. And we can see that the first consumer here, for example, received that the event that some data has been uploaded in Stuttgart, and it says on the central location, I should always download the data, and it downloaded the data in Stuttgart folder here. And if we have a look on the data here, it has been downloaded unencrypted here. And the same happens in the second consumer, which received the other event that the data has been uploaded in Hamburg. And since it's the central location, it should also download the data here. And it downloaded the data here about Hamburg. And if we have a look on the consumer group here, or the consumer in Hamburg, for example, it received all the events since it's the only consumer in that group and should receive everything. It received the events about Hamburg and Stuttgart. And for Hamburg, it says that this machine belongs to me. I am in Hamburg, so I should download the data. And it downloaded the data belonging to Hamburg here. And for the other event about Stuttgart, it says that it doesn't belong to me. I will ignore it. And in Frankfurt case, it ignored both of the events since they don't belong to Frankfurt. They are about Hamburg and Stuttgart. And if we have a look here, I'll just try to go back here to our storage account. Okay. Containers there. We see that we can only define the shared access tokens on the container level, but not on the blob level, for example. And this is something that we should keep in mind, how to structure our container and blobs things there. And for example, the user that I used here is a user that I gave the permission to upload the data. So if we have a look on our Active Directory here and go to the app registrations, where I registered the application here and see the app roles, we can see that I defined an application role called Azure Upload in this case. And then we can go back to see how we give those. So the app registration, by the way, is this application unique object that we've talked about before. And then we have our enterprise applications, which are actually the service principles that we define in this case. And in our case, I only defined one on the subscription that we have here inside this one tenant. And if we go with that service principle here, or enterprise application, and go to the users and the groups, we can see that I gave my user this Azure upload role here. And that's why I'm allowed to do this uploading process. Otherwise, I will not be able to do that. So if I just sign out here and use some other unauthorized user to do the process, I should get some error message about like access denied or something similar to that. So I'm just going to use this unauthorized user, which is not here. So I don't have the permission for that user to upload the data, and I'll just try to upload something here. And it tells me access denied, you don't have the permission to do that. So as the future or the next steps that we can do in the future, we will try to automate the whole setup and maintenance of our infrastructure using some infrastructure as code methods. We will also focus on how to structure our blob storage thing, like using the containers and blobs, and adjust our security or access policy accordingly. As I said, we can define those shared access keys on the container level, but not on the blob level. So this is something that we should keep in mind. And we will also try to implement the event capturing feature, since those events have some retention date in Azure, and after some specific time they will be deleted, and we have to decide what to do with them after that period of time. So something that we can define in Azure is use the event capturing feature to store those events in some Azure blob storage or in the Azure data lake, and then use some tools to analyze and search those data. And we are also thinking about using some utilization monitoring services to monitor the resource usage of the different Azure resources, and decide things like when to delete some containers when they are empty, and some steps like that. And with that, I want to say thank you so much for your listening. You can scan the code here to refer to the sample code that I used for the demo, and the slides are also there. And if you have any questions, feel free to ask them, either unmute yourself or write them in the chat.